In this video, we're going to see how we can use trigonometry to find the answers to slightly more complicated questions. In this first example, it says find the height and the area of this triangle. Okay, so a bit of work to do here. The first thing we should notice, it's an isosceles triangle. If these wee marks haven't been marked in your notes, mark them on, please. And this, we've got 12 and we've got 110 degrees. What we're going to do here is we're going to cut this triangle in half by dropping a perpendicular line down. So it meets at right angles and it cuts this triangle in half. So what we now have, if we draw this triangle out again, we now have got, this is very rough, but we've got a right angle triangle. This 12 has been cut in half, so it is now 6 centimeters. And 110 has been cut in half, so it is now 55 degrees. So what we want to find in this question, to find the area of a triangle, remember, I'll put this over here, we'll use this later on, area of a triangle is equal to a half times the base times the height. So we want to find the perpendicular height of this triangle. So this is what we want to find. I'm going to call this x. So we're going to use our ways of labeling our triangles, which we should be familiar with from the last two videos. So relative to the 55, the 6 is the opposite side. Again, relative to the 55, x is the adjacent side. We're going to write down our SOHCAHTOA. And we have got the O and the A. So if you've got O and A, what you're going to use is O and A is going to give us our tan. O and A, we're going to use our tan here. So we're going to say tan theta is equal to opposite over adjacent. So in this case, tan of 55 is equal to my 6 over my adjacent, which is x. So this is one of the trickier type of ones. You've got to multiply across by the x, so you have x times tan of 55 is equal to 6, which means x is equal to 6 divided by tan of 55. And if you do that on your calculator, 6 divided by tan of 55, press equals, what I have got is 4.20125. I will go for 4.20125. So I've gone to 5 decimal places. And we're now ready to find the area. So remember, our formula for the area of a triangle is a half times the base times the height. Okay, and we now know our height is 4.20125. So let's fill in what we know. It's a half times the base. The base of the whole triangle was 12. The height of the triangle we now have worked out as 4.20125. So let's just do that on our calculators. A half times 12 times 4.20125 and press equals. I have got my answer to 2 decimal places to be 25 point, well, it was 2075, so to 2 decimal places is going to be 25.21, and that's going to be centimeters squared, and that's to 2 decimal places. This question says, I walk 6 kilometers due north and then 5 kilometers due east. On what bearing must I walk to return to my starting point? How far do I walk altogether? So, quite a tricky question. It says I walk 5 or 6 kilometers due north. So that's 6 kilometers if this is my starting point. So 6 kilometers up. And then I'm going 5 kilometers east. And this is where I end up. Okay, on what bearing must I walk to return to my starting point? Right, we've got a right angle triangle. For bearings, first of all, they're measured from the north, and they're measured clockwise, and you get 3 digits before the decimal point, but we're definitely going to have our 3 digits here. So this is the angle that we're looking to find, this angle from here. So from this north all the way around to here, to get back to the starting point. Now what we could do is call this angle in here theta, and we can use our properties of trigonometry to find this angle in here theta. Once you know theta, then you can calculate this whole angle in here. So to find theta, first of all, let's label this relative to theta. This 6 is the opposite side, and this 5 is the adjacent side. So we're just going to say, write down SOHCAHTOA, and we have got the adjacent and the hypotenuse. Sorry, we have got the opposite and the adjacent, so we're going to be using tan here. So I'm going to say tan of theta is equal to O over A, and then fill in. Tan of theta is equal to 6 over 5, which means theta is equal to tan to the minus 1 of 6 over 5, which means theta is equal to tan to the minus 1 of 6 divided by 5, and see what you get. I have got 50.19 degrees. Okay, last thing we've got to do here is find our bearing. So the bearing, remember, is measured from north, so it's all the way around. Do that again. It's all the way around from here to here. So if I'd gone around the full way, all the way, including this bit here, so if I'd gone around from this north all the way around, that would be 3/4 of a turn. 3/4 of a turn is 270 degrees. So the answer I'm looking for here is going to be equal to 270 minus that 50.19. So if you do that out, see what you get. 270 minus 50.19, press equals, and what I have got is 219.81 degrees, and that is it. Okay, the last part of the question says, how far do I walk altogether? So this person has gone 6 kilometers north and 5 kilometers east, and then they walk back along this way. So we want to find this missing side here. So I'm just going to do a right angle triangle. This is just a very rough sketch, doesn't really matter about it. And I want to find this x, so I need to find this distance here. So by Pythagoras Theorem, x squared equals 6 squared plus 5 squared, which means x squared is equal to 36 plus 25. And if you add those two, 30 plus 20 is 50, 6 plus 5 is 11, so it's going to be 61. So x is equal to the square root of 61. So my total distance, which is going to be equal to, we'll give that to 2 decimal places. So square root of 61 is equal to 7.81. So we'll just say total distance equals 5 plus 6 plus 7.81. So if you do 5 plus 6 plus 7.81, it will give you 18.81 meters, or no, it's kilometers, sorry, and that really is two decimal places to 2 dps. The last example says, a man stands at the point P, 45 meters from the base of a building that is 20 meters high. Find the angle of elevation of the top of the building from the man. So we want to draw a diagram. Now, it's a very, very basic diagram. It's just a right angle triangle. There we are. This is where the man stands. He is 45 meters from the base of the building, and the building itself is 20 meters high. And what we want to find is the angle of elevation. So this is the angle at which he looks up at. So relative to your angle theta, 20 is the opposite and 45 is the adjacent. So again, write down your SOHCAHTOA and then decide which one you should be using. Now you've got O and A, sine involves O and H, cos involves A and H, tan involves O and A, so you'll be using your tan. So tan theta is equal to O over A, and then you fill that in. Tan theta is equal to 20 over 45, which means theta itself is equal to tan to the minus 1 of 20 divided by 45. And if you do that on your calculator, let's just do that now. Shift and tan. of 20 divided by 45, close your bracket, press equals, and what I have got to 2 decimal places is 23.96 degrees, and again that was the 2 decimal places. Okay, so that's the end of this video. What we have learned from this one is we need to draw right angle triangles to help us solve the problems, and then we've used trigonometry, and also, as we saw in the previous example, remember Pythagoras Theorem also works in right angle triangles as well. So a combination of trigonometry and Pythagoras to solve these problems.